Hello friends, in earlier videos we have discussed about distance relay setting calculation for line section AB for substation A and for MyCom P442 relay for mainly zone 1, zone 2, zone 3 and zone 4 reach, and with the time setting of the distance relay. In this video we'll discuss about different resistance reach settings, that is for face-to-face R-phase reach for zone 1, zone 2 and zone 3 and zone 4, and face-to-earth reach for zone 1, zone 2, zone 3 and zone 4, and also the residual compensation factor, that is KZ calculation in this video. Before going through this video, you are requested to please go through my channel and do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Now for resistance reach calculation, for face-to-face fault, the resistance that is R phase must cover the arc resistance value. Now what is the value of the arc resistance is given by Van Warrington formula, is given by RA is equal to 28710 into L divided by IF to the power 1.4, where L is the maximum spacing between the phase conductor in meter and IF is the maximum expected face-to-face fault current in ampere, and RA is the calculated arc resistance. Now for different system voltage, the conductor spacing for face-to-face gap is given in this table. That is for 66 kV system voltage, face-to-face conductor spacing is 2 meter. For 110 kV it is 3.2 meter, and for 132 kV it is 3.9 meter, and 220 kV it is given by 4.9 meter, and 400 kV it is 8 meter. It is for vertical spacing between conductor. Now what is the value of the arc resistance if the fault current is 1 kiloampere and again 5 kiloampere and again 10 kiloampere? Fault current is a variable quantity. That is why we have calculated as per Van Warrington formula based on 3 fault current level for different voltage system voltage level. For 132 kV system, for fault current IF equal to 1 kiloampere, it comes as 7.06 ohm. If the fault current is 5 kiloampere, it is 0.74 ohm, and if the fault current is 10 kiloampere, it is 0.51 ohm. For 220 kV system, as the conductor spacing between phase to phase is more, for the same fault current, that is for IF is equal to 1 kiloampere, the arc resistance comes as 8.88 ohm, and for IF is equal to 5 kiloampere it is 0.93 ohm, and for IF equal to 10 kiloampere it is 0.64 ohm. For 400 kV system voltage, as the conductor spacing between phase to phase is more than compared to 220 kV, that is 8 meter, for same fault current IF equal to 1 kiloampere, resistance of arc resistance comes as 14.49 ohm. For IF equal to 5 kiloampere, it is 1.52 ohm, and for IF equal to 10 kiloampere, it is 1.05 ohm. It is the primary value. We should convert it to the secondary value by multiplying CT ratio by PT ratio. For phase to earth fault, the R phase to earth resistance must cover arc resistance plus tower footing resistance plus tree resistance. Now for a transmission line, the tower footing resistance should not be greater than 10 ohm. Now calculation of resistance reach for different zone. First we calculate the phase to earth resistance reach, then we calculate the phase to phase reach for different zone. Now first we have to calculate the minimum load impedance, that is Z load equal to minimum voltage divided by 1.5 into thermal rating of the conductor. For Panther conductor it is 520 ampere, and V minimum is calculated by formula 0.85 into V system voltage. Here the system voltage is 132 kV. Therefore the Z load comes as 0.85 into 132 by root 3 into 1000 divided by 1.5 into 520, which comes as 83 ohm. So Z load, that is minimum load impedance, comes as 83 ohm in primary value. Now for normal operation, the earthy phase to earth resistance reach should not encroach the load impedance. Therefore the earthy phase to earth resistance reach limit should be less than 80% of the load impedance to avoid load encroachment during heaviest loading. Now 80% of the Z load comes as 0.8 into 83 is equal to 66.4 ohm. So let's take the value earthy phase to earth equal to 60 ohm. In secondary we have to multiply it CT ratio by PT ratio, that is comes equal to 60 into 800 by 1200, that is equal to 40 ohm. That is the value of the earthy phase to earth for zone 3 is 40 ohm. So for MICOM P442 relay or P44X relay, earthy phase to earth and R4 phase to earth is same, that is equal to 40 ohm. Now R2 phase to earth, that is the value for zone 2 for resistance phase resistance to earth value should be less than 80% of earthy phase to earth. So we take R2 phase to earth as 30 ohm, and again R1 phase to earth should be less than 80% of R2 phase to earth. Therefore we take the R1 phase to earth value as 22 ohm. Now again for calculation of phase to phase reach calculation for different zone, the maximum phase to phase reach, that is for zone 3, that is earthy phase, should be less than 60% of the load resistance, that is equal to 0.6 into 83, and that is the value of the load impedance or Z load, comes as 49.8 ohm. It is the limit. Let's take the value of earthy phase for safety margin, 45 ohm, and earthy phase to an R4 phase is same for MICOM relay, that is why is equal to 45 ohm in primary value. In secondary value we have to multiply it into CT ratio by PT ratio, which is comes as 45 into 800 by 1200 is equal to 30 ohm. Now earthy phase and R4 phase value for MICOM relay comes as 30 ohm, and R2 phase should be less than 80% of earthy phase, that is should be less than 24 ohm. For safety, let us take R2 phase equal to 22 ohm, and R1 phase should be less than 80% of R2 phase, that is should be less than 17.6 ohm. Let us take R1 phase equal to 16 ohm. Now calculation of residual compensation factor for earth fault, that is Kz. Kz is given by Z0 minus Z1 divided by 3Z1. We have discussed the importance of Kz value. The Kz value must be given properly, otherwise the distance relay will be unable to locate the exact position of the fault during phase to earth fault. Now the line parameter for 132 kV transmission line is given in the below table. Since all the line are double circuit line, we will take the R1 and X1 value, that is positive sequence resistance and positive sequence reactance value, as 0.14 ohm and 0.4010 ohm respectively, and R0 and X0 value as 0.35 1.40 and 1.33 value respectively. Now Z1 is equal to that is the positive sequence impedance value, that is equal to R1 plus I into X1, comes as 0.14 plus I into 0.401 equal to 0.425 at an angle of 70.75 degree. Now Z0 is equal to zero sequence impedance of the transmission line, comes as Z0 equal to R0 plus I into X0 equal to 0.354 plus I into 1.33, comes as 1.376 at an angle of 75.09 degree. Now the value of the residual compensation factor, that is Kz, comes as Z0 minus Z1 divided by 3 into Z1, which is Z0 equal to 1.376 at an angle of 75.09 minus Z1, which is 0.425 at an angle of 70.75 degree, divided by 3 into Z1, which is 3 into 0.425 at an angle of 70.75, that is comes as 0.75 at an angle of 6.22. The value of the Kz for all the zone should be same, since the subsequent line are the double circuit line and this double circuit single panther conductor. If it is not double circuit line, instead of single circuit line for zone 2 or zone 3, the value of the Kz will be different. So friends, if you like my videos, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching.